Welcome, everybody. I am delighted that you're able to join us for today's MTI research webinar, which was entitled Electric Vehicles, Past, Present, and Future. And today's speakers, Dr. Gijs Mom and Dr. Daniel Sperling, will be exploring the long history, current state, and future potential of this critical technology. My name is Dr. Asha Weinstein Agrawal, and I'm the Education Director at the Mineta Transportation Institute here at San Jose State University. And we offer, as a side note, an online graduate program in transportation management. And if anybody is interested, for you or your colleagues, we have lots of information online. Reach out later and we can share that. MTI as an institute leads actually two multi-university competitively selected consortia. There's the Mineta Consortium for Transportation Mobility, funded by the US Department of Transportation, and the California State University Transportation Consortium, which is funded by California's Senate Bill 1. And MTI's mission at large is to increase mobility for all by improving the safety, efficiency, and accessibility and convenience of our nation's transportation system. Today's webinar is focusing on lessons from the history of electric vehicle technology and policy innovation that can help today's policymakers and automotive experts smooth the past for a cost-effective adoption of electric vehicles. Now, although many people think of electric vehicles as a newfangled, cutting-edge technology, there have actually been electric versions of the so-called horseless carriage for almost 2 centuries. So clearly, there is a fair amount of history for us to learn from. Now, today's presentation was scheduled in honor of Earth Day, which is coming up on the 22nd, because we recognize that electric vehicles have the potential to significantly contribute to creating a more sustainable transportation system. And I am honored to now introduce more formally our two distinguished speakers, Dr. Gijs Mom and Dr. Daniel Sperling. The MTI webpage for our event has a much more detailed description of their long lists of accomplishments, and I'm just going to share a few highlights today. Dr. Gijs Mom is Associate Professor Emeritus at the Eindhoven University of Technology in the Netherlands, and he is a global expert on automotive history. Among his many scholarly publications on transportation technology and history are a book titled The Electric Vehicle, Technology and Expectations in the Automobile Age. Dr. Mom founded the European Center for Mobility Documentation and co-founded a wonderful organization, the International Association for the History of Transport, Traffic, and Mobility. Dr. Daniel Sperling works at the University of California, Davis, where he is Distinguished Blue Planet Prize Professor of Civil Engineering and Environmental Science and Policy. He is also a founding chair of the UC Davis Policy Institute for Energy, Environment, and the Economy. Dr. Sperling has been recognized for 3 decades as a leading expert on transportation technology assessment, energy, and the environmental aspects of transportation. And since 2007, he has served as an appointed member on California's Air Resources Board, which sets many of the state's critical policies on electric vehicles. So for today, Dr. Mom and Dr. Sperling are each going to present some opening comments that are going to give us a sort of whirlwind history up to the present of electric vehicles, and then we'll turn to questions and answers. So if you have questions for our presenters, by all means, please share them through the chat. I'm actually not sure if the Q&A feature is enabled right now. If it is, you can use that too, but actually the chat is a little bit easier for if you don't mind throwing your questions in there. Also, I will mention that we're recording the webinar, and the link for viewing it will be available within a few days on our website and social media pages. So with that, let me turn to Dr. Mom. Would you like to begin? And I know we have some slides that we will put up if yours now too. Alvarina is helping run the technology. So Alvarina, can you advance to the next slide?
Okay.
Take it away, Dr. Mom.
Thank you, Asha. A good afternoon to you all, and good evening to those of you who are in Europe. In my introduction, I would like to emphasize the issue of expectations in the history of the car and the electric vehicle in particular. This, for instance, is a picture from 1900 in a Dutch engineering journal, probably taken from a British one. I'm not sure that you are familiar with this cartoon or image, but it says a lot to me. It says that the engineering tribe, so to say, in 1900, when the internal combustion engine car and the electric vehicle already were on the streets, imagined the future as one of a kind of congestion of the air. Of course, that is a fantasy, because at that moment the airship and the balloon were very popular. I'm not sure how I can get the next one. Asha?
Just say next slide and we'll advance them for you.
Oh, you do that. Okay. So, and also there were experts in electric vehicles who at around the same time, before 1900, here in Germany, fantasized about the future of the electric vehicle. You see the street is still non-asphalted, but the way of propulsion is done by a wireless transmission of electric power. Next slide, please. So the question of these expectations are for me very important. So I dedicated a large part of my dissertation on this. And, you know, spoiler alert, the conclusion of this dissertation was that it may be contrary to what many people think, the so-called failure of the electric vehicle was not so much technological as it was cultural. I will come back to that later. But in any case, when I finished that dissertation, it was clear to me that I had to understand the so-called failure of the electric vehicle by analyzing the success of the alternative, the internal combustion engine. So why is the internal combustion engine so popular, and was it so popular? And I dedicated 3 volumes to an analysis of this question. The next slide. So first I analyzed the Western ICE car, and these 2 books, one was published last year, and the other, the sequel, is appearing in September this year, is dedicated to the globalization of car culture. And the question is pursued throughout these 3 books. Why is the ICE car so enormously popular? Although since the early 1920s, most people realize that it is not the best solution for all kinds of problems. Next slide. So coming back to the electric vehicle, this is one of the plans by experts also before 1900 of an electric home, an electric house in Paris. And this was realized, as we all know. We have electric refrigerators, we have electric washing machines, except the car. The car here, G, is an electric vehicle, but we all know that for the next 100 years, the vehicle was propelled by an internal combustion engine. Next slide. that does not mean that, the next slide, please. That does not mean that, yes, thank you, that there were no electric vehicles applied. This is, for instance, a nice example, and this also of a taxi cab, Krieger, the largest manufacturer in Europe, popular in Germany, in several cities, in Paris, in London, in another version, and in Amsterdam and Haarlem. The next slide. In my dissertation, I could do a calculation of the fleet of about 80 electric cabs in Amsterdam between 1909 and 1921. And as you can see, we are talking here about, well, what at that time was high-tech vehicle technology, because these vehicles ran more than 30,000 kilometers per year each. So we are not talking about old-fashioned or defective technology. This was state-of-the-art around the beginning of the First World War. And also in terms of costs, yeah, the next slide, please. In terms of cost, the differences between the electric cab and the gasoline taxi cab that also was around was minimal. Next slide. That was Europe. This is the United States, Boston, New York, Detroit, several cities, Newport, where these taxi cab fleets were very successful in the beginning. And this is another way of management of such a fleet. As you can see to the right of the picture, you see a set of batteries. And this was a fleet that was used on the basis of mass exchange, the exchange of the batteries. And it was very successful. It failed because of reasons I cannot go into in full detail, but it was a kind of speculation in lead acid battery technology. But the fleets itself were very well functioning, and also the technology of the batteries, and especially the tires, that was one of the problems, was considered to be more or less solved. Next slide. And the next. So that is fleet technology, where most experts knew that the electric vehicle was could be very successfully applied. But there was also this individually applied technology, like this racing car. The first car that drove faster than 100 kilometers per hour in Paris. And the next slide. But also it was applied in electric trucks, for instance. And this slide shows you 6-ton fire engine trucks with electric motors in the hubs of the wheels. So there was no problem whatsoever of technology leading to the failure of these experiments and these practices. So the next one, even because you might think, well, how about action radius? This is a tourism called electric tourism, the Detroit Electric, one of the most popular cars in the United States, which was possible, and I explained that in my dissertation, because at least on the east coast of the United States, there was a vast network of fast charging stations that if you were willing and able to plan your trip, you could practice this kind of electric tourism. So, and yet, when we talk about electric tourism, we are talking about beginning of the 1920s, we see the electric vehicle fade from the scene. And the question then is, how is that possible? Why is that so? If all the experts said, this is the car of the future, what I remember an interview from 1900 where a fleet manager said, well, steam is for trucks, gasoline is for the rich, and within 10 years that fashion will fade away, and the future is electric vehicle. And we all know that it did not happen. Next slide. And I could tell this story, in fact, over and over again in several generations, and generation here defined as a technological generations. I cannot go into details, but it was different types of lead acid batteries, different types of tires, different types of bodies, and so on, and different applications. For instance, the fourth generation, if we focus on that, the next slide, we see that in Germany, a new culture of electric vehicles is coming up. For instance, delivery vans by the German mail service. Next slide. But this fourth generation is also the generation with, as well, some of you might have experienced, I at least have done, the Clean Air Act in the US, very important. And most experts at that moment concluded that for this generation, the EV cannot compete with mainstream vehicles in terms of reliability, costs, and action radius. And my point here is that this conclusion has been projected back into history, but it is that is not a good way of doing history. As I showed you, the first experiments and the first applications were highly successful. So next slide. There is even a fifth and a sixth generation, the next slide, in which I myself was active. Here you see some experiments in the northern part of the Netherlands. The next slide. A big activities. Yeah, in the south of France, for instance, here, all kinds of applications, vans, little sleeping trucks, and electric passenger cars. And the next slide. And of course, let's not forget that the EV1 in California. And most of you, oh, sorry, the next slide. The EV1 in California, and we all know that what happened with that fleet. I assume that Dan will in a minute continue this history by telling us something about what happened here. I think that this is one of the big chances that were missed. Why that is so, we can discuss later, I hope. But in any case, in the end, the next slide, we know that this promising fleet was scrapped, and there is a nice movie about that that tries to explain why that is the case. So I would like to leave it at that. Oh, maybe the next slide to end my talk here is that I would like to finish with some projections that are more recent. US Congress in 1976 predicted that there were 10 million in, I cannot read it, 2010, I think. Oh no, sorry, 2000. Japan that predicted that there would be 200,000 vehicles in 2000, and so on. So the question that we should solve this hour, I think, is why is that so? And I would like to leave it at that.
Thank you very much, Dr. Mom. And so now for a little bit more recent whirlwind history, we're going to turn to Professor Sperling.
Well, thank you very much. It's a pleasure to join you and join Gijs as well. We actually met over 25 years ago in Europe, and he actually back in California as well. So we have a long history. So updating the story of electric vehicles, picking up where Gijs left off, is the EV1. So let me break it up into, I'm going to talk about products, I'm going to talk about policy, and just a bit on technology, those three streams. So we talk about the products. The EV1 made by General Motors in the mid-90s. And actually that was the car, the prototype of that is what inspired California to adopt an electric vehicle mandate. There'd been an interest in that in the late 80s, mostly for air pollution reasons in the LA area. But when the regulators and politicians saw that prototype, they said, aha, that means GM can do a modern EV. And so getting ahead of myself a bit, but in 1990, California adopted the zero emission vehicle mandate, which was the first modern policy in the world to promote electric vehicles. And it called for 2% of all vehicle sales being zero emission by 1998 and 10% by 2003. Now, obviously that didn't happen. We'll get back to that. But so anyway, so the products of the General Motors came out with the EV1, and a lot of companies came out with different electric vehicle models in the 1990s. Toyota had its RAV4 electric. Ford had its Ranger pickup. So there was a lot. In fact, most car companies were developing models because they thought this was really going to happen. But it turned out that, both for cultural and economic reasons, we weren't ready for it. But then the real breakthrough came in 10 years later, in the mid 2000s, when Tesla came along. And Tesla is the real story for the modern EV. So we all can think whatever we want of Elon Musk as a person, but he's been brilliant in what he's accomplished with that company. And so they released first a Roadster. Basically, it was like an EV1 in many ways, as their first model, $100,000. People like Arnold Schwarzenegger bought it, celebrities and others, but they only made a similar number of it to the EV1, about 1,000 of them. But then General Motors came with the Volt, which was a plug-in hybrid actually, and Nissan with their Nissan Leaf, and then Tesla with its Model S, all 2010 to 2012 or so. And that really spurred the new generation of EVs. That was really when it started taking off. And part of it was in 2012, the California Air Resources Board, and I'm a board member of it and was at the time as well, we updated that ZEV mandate. We'd been kind of weakening it, every 2 years from 1990 up to 2012. But in 2012, tightened it up and imposed some pretty aggressive requirements. So that got the attention of the industry, and that's what really started spurring, the modern industry of EVs. So right now, so I should put in one more car, the Toyota Mirai, which is a zero emission vehicle, but runs on hydrogen with fuel cells, but is zero emission. The hydrogen has not really taken off. And we can talk about that a little bit because I think there is a possibility it will make a comeback in the future. So meanwhile, here we are where Tesla is making almost half the electric cars in the world. Norway is over 90% EVs now, sales of their sales. We've got Germany over 20%, Sweden, number of European countries. China is also now over 20%. And so the market really has taken off. So it's really happening in Europe, China, and in California. So just 2 days ago, California on the policy side, California just, CARB, my agency, I call it my moonlighting job because I'm primarily a professor. We adopted at CARB a new rule that is going to require 100% of sales to be zero emission by 2035. So it starts in 2026. It'll take effect that in that year, 35% must be zero emission. That goes up to 68% in 2030 and 100% in 2035. And Europe is considering similar regulations and requirements now. And China is doing something similar too. So, it's happening now. I think there's no question that EVs are going to not only dominate, but, really vanquish the combustion engine vehicle. The question is when and how fast. It's not if. And I should point out one other thing before we go on, and that is that actually the same thing is happening with trucks. It's lagging a few years, but California, for instance, adopted CARB again. We adopted a requirement that by 2035, 75% of most truck sales must be zero emission. So there's different categories. So the long haul trucks, it's 40% in 2035, 75% of most of the other trucks. So we're going to see a similar path with trucks. And it really all comes down, at this point, it comes down to economics. And that the story is that, first of all, the battery costs have been reduced by, 90% or so in the last 12 years since 2010. And that's what's is bringing down the costs, and the costs are expected to continue going down. We've gone from lead acid in the 90s to nickel metal hydride in the 2000s, and then lithium ion batteries, which have been continually improved and cost reduced. And there's likely to be new types of batteries, solid state in the future. There's already companies gearing up to manufacture that. So the story is the costs are continuing to come down. They're not plateauing. And that's really the explanation why everyone expects zero emission vehicles to really dominate. So let me leave it there. And I think that's kind of frames it generally where we are.
Well, thank you both very much. So now we get to turn to questions, and there are lots of interesting ones that are coming in the chat, but let me just ask one of my own first, and then we'll get to those. So Dan, you just mentioned that costs, are coming down considerably for batteries, which will probably be critical, and you're anticipating that, yes, it's when, not if, EVs become a dominant technology. Hayes, I think, is a little bit maybe more skeptical about that. So let me ask both of you, since people have been predicting that EVs are going to take over for more than 100 years, is today actually the turning point when we will see ICEs kind of fade away and electric vehicles become dominant? And what are the reasons? Is it just cost, or are there other things right now that make such a transition much more likely?
May I start by saying, just to be a bit provocative, that helps keeping up the debate, that I'm not sure that we are at a turning point. Dan is very convinced, and he is talking about when instead of if. I'm still in the if position, because if you see all these 6 generations that did not result in the dominance of electric vehicles, while the experts every time said, this is the vehicle of the future, it is the rational vehicle, and they were right. So then I ask, what is new now in terms of turning point? And I see two things: the climate change issue, and of course the Ukrainian war, and the fact that the electric vehicle and the internal combustion engine vehicle is becoming a kind of geopolitical instrument. I think these 2 points are relatively new, although, of course, we have witnessed the energy crisis of the 1970s, where also was a big urge of activities around the electric vehicle. And let's not forget, the car manufacturers invested hundreds of millions of dollars in the electric vehicle at that time. And the experts were saying, we are on the brink of an electric future. So that Dan is talking about, for instance, especially the European markets that are very promising, apart from China. In the United States, it seems less promising. But let's not forget that in Norway, the subsidy on these cars is very high. And there's another point that I would like to stress. Maybe Dan can say something about that. In the Netherlands, for instance, I have been asking the experts who calculate, for instance, the advantages of the electric vehicle versus the internal combustion engine car, the cradle to grave calculations, as they are called. And one of the policymakers, critical policymakers in the Netherlands, said to me, well, we don't talk about that anymore because we put the electric vehicle in the traffic policy side, whereas all the other elements of the cradle to grave calculation, like production, recycling, and so on, we put that in industry. And that's why we call it a zero emission vehicle. And we emphasize that. So I asked him, can you give me some calculations that clearly show me that the electric vehicle is, in terms of cradle to grave calculations, better than the ICE car? And he said, well, for the Dutch mix of electricity, it's a bit better than internal combustion car. But for instance, in China, that is not the case. And in Norway, of course, with the water propelled electricity, it's for sure. So that's my main doubt that I have, and I want to lay that before Dan. So how do you look at that? This in the 70s and 80s and the 90s, we talked about cradle to grave, and I don't hear anybody about that anymore.
So you missed one important factor that explains everything, and in fact responds to some of the questions in the chat. Economics. It is now, the cost has come down so much on the batteries and the vehicles that within a few years, most electric vehicles in most situations will be cheaper to own and operate than a gasoline vehicle or a diesel vehicle. And so the initial cost will still be higher, for quite a few years yet. But the operating cost is less maintenance. And so if even now, if you drive the vehicle more than 25,000 kilometers a year, 15,000 miles a year, for most of these models, they make sense, including the Teslas, if you look at comparable vehicles. So it's the same story with trucks. In fact, it might even be more positive for trucks because a lot of these trucks are delivery trucks. They have they only run 100 miles a day, and they have pretty regularized routes. And so, you don't have to build these huge battery packs I mean, part of the craziness now, I mean, there's two crazinesses going on. One is in the US, especially, people are getting bigger and bigger vehicles. You know, like the F-150 is, you know, it's going electric, but it's a massive vehicle.
Yeah.
And so vehicles have gotten massive, number one. And number two is people want these big batteries for long ranges. And I think that'll go away. But with the big batteries, they do get expensive and heavier, and therefore also less energy efficient. So the answer is economics, and that is why EVs, you know, someone wrote a note about, well, these are just regulations and who follows regulations. But this is a case where the economics are getting so positive that the market is going to take over at some point.
So Dan, let me just quickly follow up. You've made a very convincing case that the economics alone signals a shift to EVs, but do you think that either the current increased concern about climate change or the very recent concern about fuel in the Ukrainian-Russian war, do you think either of these matter, or really they're just kind of noise and it's the cost that's going to drive everything?
Well, certainly climate is what's motivating public policy at this point. You know, it takes time for these politicians and presidents and prime ministers, you know, they can say whatever they want, but it takes a long time for them to say that until it actually becomes a real law or regulation or incentive. And so, you know, the Ukraine thing, it's a horrible situation. I don't know how that's going to play out, but climate is a sustainable policy, and that is what's motivating it. And we do need it because, you know, the vehicles are going to be more expensive, and the reality is that people don't buy vehicles based upon the total cost of ownership, and they buy it based upon the price of the vehicle. So we will need incentives and other initiatives in place for a number of years, even though it's good for the consumer and good for the economy.
So let me pose another question that comes out of what's in the chat and reflects back on what you were just saying. Both of you have mentioned, you know, there's a choice of how big and powerful these vehicles are, and if they all have huge batteries that are enormous, as Gijs pointed out, they may not actually have such a great cradle to grave efficiency. So along those lines, one of
Wait a minute, can I
Yes,
address that, you know, before
Oh,
I
yes,
let it
please.
go?
Mhm.
Okay, so, you know, the cradle to grave, there's two parts to that. One is the energy used for manufacturing the vehicle and the batteries. And that represents, at least like with today's vehicles, that represents about 15% of the lifetime emission, you know, or so. So it's important, but it's not the dominating factor. And as we use renewable energy for electricity, then even that carbon footprint goes down. And then it becomes how much of the electricity mix is renewable energy and nuclear energy. And in a place like California, where we use relatively little fossil energy, the cradle to grave number, the life cycle analysis for EVs is extremely positive. You know, you would say the same thing about France because it has a lot of nuclear energy. But even for like the US overall, which still uses a lot of coal, it's still at least, I haven't looked at the latest numbers, but on average, it's at least 50% better, probably 50% better than a gasoline vehicle life cycle emissions. And it's just going to get better as we decarbonize the electricity system.
Mhm.
Now, I don't, Gijs might disagree with that. And that varies, you know, again, it varies how the electricity is made.
And so I think
Maybe one small remark about another aspect that we did not discuss till now. That is the distinction we should make in this debate between experts and motivated people of the middle class that we all are, and the majority of the earthlings that are not part of that class and do not have the means to buy new cars. For instance, 50% of the cars in the Netherlands now are so-called company cars. The new cars are leased and so on. So if we talk about the chances of the electric vehicle becoming more than 15 or 20% of the market, we have to discuss the issue of people who cannot afford a new car, and still, and that is my other point, consider the electric vehicle as not what they understand as a proper car. And that's my cultural argument. And I think that is still playing a role in many markets. And as far as I'm concerned, also in the Chinese market, where the central government subsidized electric vehicles to a large extent. And most of these subsidies, and I'm now talking 5-7 years ago, Dan may have more recent information, but most of these cars, most of these subsidies were not used by the prospective motorists. They simply did not want to buy electric. And I think Dan may have a point about his economics, but I think there's also an important cultural issue here that still many people in the markets consider the electric vehicle as not a proper vehicle, whatever Tesla is trying to do. So for me, the road is not through Tesla. It is through the urban van, the delivery van, the trucks, those vehicles that have to stop a lot but the Tesla road is a dead end road.
Well, okay, I'll go gloss over your last sentence, but you make a very good, I'll come back to it though. You make a very good point. So in Europe, in many countries, as you said, half the cars are company cars. And that distorts the market because that's not a normal person buying a vehicle, and the vehicles tend to be a little bigger. They have attributes are not what most people would want. And then the other part is in the U.S., new cars are only purchased by about 1/3 of the households. All the new cars are purchased by 1/3 of the household, and that distorts the market because these tend to be more affluent people. And they get these bigger vehicles, and then everyone else is stuck, with what that smaller number of households purchased. So that's a really good point. And I think what's going to happen is, so looking at the U.S. market, and my institute, we're doing a lot of work in Europe now as well. So we're in the process of setting up a European center of our institute in Brussels and Paris. But so what's going on is that we will get to a point, in Europe, maybe it's 20 or 30% because a lot of people live in apartment buildings and in multifamily dwelling. I think it's more than 20 or 30. I'd say for Europe, it's more like, 50% might be where it gets problematic. In the US, it's probably more like 70%. But there gets to be a point where there are people that are just ideologically opposed. There are people that live in apartment buildings where it's difficult to get charging. And there's people with applications where it might not be, well suited to them. So we are going to run into a challenge. I mean, plug-in hybrids are part of the answer. So California has changed its policy. We used to think we were going to phase out plug-in hybrids, but the new policy is we're going to keep them as part of it so that, people, because then you can operate it, you get the benefits of the gasoline vehicle and, for part of the time when you need it. And that's where I think hydrogen might make a comeback also, where a hydrogen vehicle can be fueled basically just like a gasoline vehicle, and you don't have the charging problems. So, but I think the point is well taken that, we do adopt regulations but there's often pushback, there's politics. And at some point, there are going to be big challenges coming up. I think the first 30 to 60% is going to actually be relatively easy as long as we have the incentives in place. And I actually think it's going to get harder later on.
Yeah.
So we've had a number of questions that relate to charging infrastructure. And I admit I was struck to learn that there were battery swapping stations in, I don't know, 1920s or wherever that was. So do either of you have any ideas to share with the group about what we can maybe learn from the history of charging infrastructure and what either seemed to work or didn't that may help us as we go forward?
Well, may I? The history of the electric vehicle is not only a history of failed experiments, failed mostly culturally, because often the majority of the population didn't consider the electric vehicle a real vehicle. But the history of electric vehicles is also a history of missed chances, and one of the missed chances, in my opinion, is what at the time was called mass charging, the exchange of batteries. That was one of the success formulas of these fleets in New York and also in Amsterdam, for instance. And I know there was an initiative in, what was it, in the 1990s in Israel, Better Place, I think it was.
Yes.
But then we hear from that again, and I know there are economic arguments against it, but I think in the beginning at least, it was a promise. It could have saved the electric vehicle from losing. That is my idea. I don't know whether that is the case now. Dan should know that, but that is one of the missed chances, I think.
So, the reduction, as battery costs come down and we put more batteries in the vehicles and get longer range, the battery swap and other types of ways of dealing with, the charging the battery become less important. And it's just because, the vehicles, they all of them have over 200 miles now, many over 300 miles of range. And at least for the initial buyers, they mostly have a way to charge at home. And so most in the United States now, about 85 to 90% of the charging is done at home. And so that's easy. That's actually better than a gas station. That makes it actually one of the attractions of the EVs. Now, the battery swapping, actually Tesla tried battery swapping. There's a battery swap station on I-5 between halfway down the state for anyone. It was in an old car wash station at Harris Ranch, if anyone wants to, for historical reasons, go see it. But they shut it down. And where it's really happening is in China. So China is doing a fair amount of battery swapping. There's a company, NIO, one of their big EV manufacturers, that does have a whole network of swap stations. But my assessment, my colleague at UC Davis, Yunchu Wang, who works with Chinese, is really excited about battery swapping. There's a company in San Francisco that's doing battery swapping. I think the real future of it is with fleet vehicles that have, a company or an organization that has a whole bunch of vehicles. They're all the same, and they just can swap them out, the batteries. And I think that's where it has an application. But otherwise, you got to have a huge inventory of batteries, because otherwise all the companies have to agree to have the same size and type of batteries. And companies can't even standardize their own vehicles, much less across companies. And then you need a big inventory, which is, to save them up for all the different types. And then people get worried they're going to get a cheap, worn out battery, and they bring in their good one. So there's so many problems. So I think the fleet application, though, is a good thing. It is a promising, but not for individual consumers.
A kind of socialist solution.
How is that with the fleets, you mean?
Well, because all the cars are the same.
Oh, that would be a socialist solution, right?
So we're getting to the end of the hour, but we've had a lot of people who've also written in questions about incentives. And so let me ask, government on the one hand can pass regulations and require manufacturers to sell vehicles, but also we obviously spend money as public sector agencies, and that can be subsidizing individual people to buy vehicles. It can be building or subsidizing charging infrastructure, and it can be investing in research and development. So going forward, what do you think might be the most valuable ways that we can spend public dollars to support EV adoption? And since that's the theme of our talk, what can we learn from the history of what's been done in the past?
Well,
May
I've got an answer, but if you go ahead.
May I say, can you show the last slide of my presentation, Asha? Will that work?
So maybe. Alvarina has
Well,
left.
anyway, my answer would be that we should not look at the electric vehicle problem, so to speak, as a problem of innovation only. That we tend as experts and especially as engineers to focus on innovation. And I would like to show the photographs I made in China, 3 years ago, to indicate, well, that's not my photograph.
Oh, is this not what you were hoping for?
We get about, when we talk about sustainability, we should also talk about other alternatives than the electric car. My teacher of internal combustion engine technology long ago said the key to the climate problem is the ignition key. So that's about using cars less. But the other solution might be, especially in an urban setting, the bicycle and what you see here, electric motorcycles. I think I have seen an estimation for China of 150 million of these vehicles. Can you imagine what a pollution that represents if they had been equipped with internal combustion engines? So innovation is really important, but we also should look at the simple things that we can devise ourselves to solve the problem of the climate change.
Yeah, I agree. Actually, what you're talking about, makes a lot. I'm working with in the country of India, and they've got, even more than China, they've got all these 2-wheelers and 3-wheelers, and electrifying them and figuring out innovative ways of charging them, and using them for public transportation as well is part of the solution. But the answer to Asha's question is, I have one word answer: fee baits. And then, so I'll describe. So fee bait is the idea. In Europe, the French call it bonus malus. The idea is that if you buy a gasoline or diesel vehicle, you pay a fee. If you buy an electric, you get a rebate, and you design it so that the fees match the rebates. And that way, there's no taxpayers pay nothing, government pays nothing, and it sends a strong market signal, in a way that we'd like to see it. So, in Europe, there's been some of that. Different countries have done. Sweden has a version of it. They do it through their registration tax, and I think that's the best answer, because the incentives in California have gotten really garbled. I saw there were a couple questions about it in the chat, is that, we want it to be point of purchase, because if you do an incentive where you get, $4,000 back a year later, that really has a relatively weak impact on your purchase decision, as opposed to getting it right in hand at the dealership. So you want it point of purchase. We want to make it so that it doesn't go to all the rich Tesla owners. And lots of people on the chat are very antagonistic to Tesla, so I understand that. And so you want it to go to people, that have less, aren't rich and are probably going to buy it anyway. There is the tension, though, that we got to get volume out there, and the incentives do help. Even rich people are responsive to incentives. It's kind of interesting that we've seen in our research. So the incentives in California, I shouldn't say it's a mess, because people at my agency will get mad at me, but we've got several different ones. They're not guaranteed because it depends on the legislature making the funds available each year. And it's got to be streamlined. It's got to be more certain. It's got to be point of purchase, and it should be pointed at people, that are less affluent, less affluent. So that's why fee-based is so simple. It's the answer. I'm going to go back and work with the legislature and try to explain to them why this is the best approach.
Okay, well, thank you both so much for a really thought-provoking discussion. And hopefully, we had a great turnout in our audience. So hopefully there are people who are making decisions in this world, and we'll go back and reflect on the history and what that can teach us going forward. Just to wrap up, I would like to mention that MTI has a whole series of events. This is just one of many, and I encourage you to check out others. Two quickly that I'll mention is we do have online information sessions for our graduate program in transportation management. There's another one coming up in May, and it's an incredibly affordable program. You can get a master's degree for $13,000, taking your classes online, and with a chance to have all kinds of amazing faculty and guest speakers from industry as well as academia. In terms of MTI events, we also have one of the many on June 3rd is a symposium virtual on equity and road user charging. And our featured speakers are going to include Congressman Peter DeFazio, who's been head of one of the congressional committees on transportation, and also Assistant US DOT Secretary Polly Trottenberg. So please keep us in mind when you want a little bit more tech transfer and education. And once again, we will be posting the recording to this session if anybody wants to rewatch it or pass it along to colleagues. And let's please give a virtual round of applause to Dr. Mom and Dr. Sperling for joining us today. Thank you so much.
Thank you very much, Josh.
Thanks. Bye, everyone. Great
Bye.
questions. I'm sorry we couldn't answer all the chat questions.
I think the best question we didn't address from the audience is, what is after EVs? I don't have a clue.
Smaller vehicles is definitely part of the answer.
Yes, I hope so.